Something extraordinary is happening today. It's one of those moments when someone has the inspiration and courage to test a profound new idea. Lurking in the heart of a giant elliptical galaxy is an invisible leviathan so terrifying, it defies the imagination. It warps the very fabric of space and bends the flow of time. Anything that approaches is trapped by its gravity, never to return. It's a supermassive black hole in the center of galaxy M87. Now, history is being made. A direct photograph has just been released.
And we are delighted to be able to report to you today that we have seen what we thought was unseeable. We have seen and taken a picture of a black hole. Here it is. This is a remarkable achievement. What you're seeing here is the last photon orbit. What you are seeing is evidence of an event horizon. By laying a ruler across this black hole, we now have visual evidence for a black hole. We now know that a black hole that weighs 6.5 billion times what our sun does exists in the center of M87. And this is the strongest evidence that we have to date for the existence of black holes. And it is also consistent, the shape of this shadow, to the precision of our measurements with Einstein's prediction.
But I remember very vividly when I saw the first picture, and it was a humbling experience. I didn't know whether to scream happy or to feel, the weight of the moment.
To obtain such an image, astronomers understand one principle: bigger is better. The bigger a telescope is, the better the resolution of its pictures. When it was new, the 100-inch telescope at Mount Wilson was the largest telescope in the world. Using this instrument in 1929, astronomers discovered the universe expanding. By using the new 200-inch telescope at Palomar in 1963, they discovered the brightest objects in the universe: quasars. Each increase in telescope size yields a leap in our understanding of the universe. Radio astronomy works the same way. Radio is a form of light, so the size of the radio dish matters. Among the largest is in Puerto Rico. The primary dish is 305 meters in diameter, over 1,000 feet across. But radio astronomers have learned a trick. At the Very Large Array in New Mexico, they have 27 dish antennae, each 25 meters across, arrayed in a Y-shaped configuration. Using a technique called interferometry, these antennae work together as a single instrument with a collecting area over 22 miles wide. This collection of dishes gives the telescope resolving power far beyond any individual dish. But astronomers wanted more. Enter the Event Horizon Telescope, better known as the EHT. Using the interferometry technique perfected by Very Large Array, the EHT is made of radio telescopes working in concert all over the Earth. This is possible because of one powerful feature. Interferometry doesn't care how far the antenna dishes are separated, as long as they're precisely synchronized. The combined antennae work as though they're a single telescope, with a collecting surface as big as the distance between them. With antennae located in Hawaii, North and South America, Greenland, Europe, and the South Pole, the EHT has a collecting surface literally the size of the Earth. And it gives the EHT the resolving power to do the unthinkable, to see the supermassive black hole in the heart of the M87 galaxy.
Black holes were mathematical curiosities. They were solutions of Einstein's theory of general relativity. And for the longest time, for decades, people did not think that they were real objects. What the Event Horizon Telescope has allowed us to do is go and look there for the very first time with a resolution to see the black hole.
The implications of this new photo are enormous. Relativity is no longer a theory, it is a fact.
Today, general relativity has passed another crucial test. The shadow exists, and the inferred mass matches estimates due to the dynamics of stars 100,000 times farther away. The object at the heart of M87, the object that powers M87's jets, is a black hole like those described by general relativity. Today, science fiction has become science fact.
Computer simulations that mimicked what the EHT might see were promising. They showed a well-defined shadow region. This is the event horizon itself. The boundary wall where anything can enter, but nothing can leave. Astronomers believe that a process called spaghettification occurs around the black hole. An object falling toward the center of the hole feels the power of gravity rising so fast it becomes torqued and stretched into strands like spaghetti. No physical object can survive this process. At the center of the hole is the singularity. It is an object compressed and squeezed into a single point. It has no dimensions left to it, no height, length, nor depth. It's an object where the physical realm and the laws of physics as we know them have broken down. And yet, it retains the gravity of all the mass of every object it has ever devoured.
So this is an easy way to visualize how a black hole shadow is formed. We can start by looking at what happens to light when we have just flat space. And as our normal experience is, light just follows straight paths. But if I put a black hole in the middle, the black hole will warp the space-time all the way to the singularity. It takes light rays and bends them, and some of them actually go straight down the neck of the singularity.
A shadow is what a black hole casts on its surrounding emission. So as gas gets close to the black hole, it heats up, it emits light. The black hole space-time, with the presence of the horizon and with the presence of a density depression at the center, absorbs all the light there. So it leaves a central darkness, which we call the shadow that the black hole imprints on the image.
Black holes come in sizes ranging from nanoscale to thousands of times larger than our entire solar system. The diameter of M87 is roughly 24 billion miles across.
Black holes are major disruptors of the cosmic order on the largest scales in the universe. M87's huge black hole mass makes it really a monster, even by supermassive black hole standards. So you're basically looking at a supermassive black hole that's almost the size of our entire solar system.
Monster black holes like M87 are large because they're old. It's likely that such objects are primordial. That is, they formed just after the birth of the universe itself. The quasars first observed in the 1960s at Palomar are believed to be supermassive black holes. They grow so fast, their gravitational power rises, allowing them to feed on more and more.
Previous epochs that it was feasting on something. There must have been a lot more stars and gas that were just feeding it. M87 grew to be billions of solar masses.
Nothing is safe. Matter rushes into the hole so fast and at such a volume that a traffic jam builds up around them. A disk backs up, and some of the material is trapped in tangled magnetic field lines surrounding the hole. This material escapes along the magnetic pole of the black hole. and create gargantuan torches lighting up the intergalactic night. Historically, scientists have relied on artists to help them visualize the shape and nature of black holes. But we'll no longer have to depend on the guesswork of their creativity.
Yeah, I mean, there's always going to be stuff we can't resolve directly, and the artist's conception of whatever other phenomena is going to be valuable.
Above all, this monumental picture and the Earth Horizon Telescope itself serve as yet another example of the genius of the human mind and the power of its curiosity to probe and understand the universe.
And this image forges a clear link now between supermassive black holes and the engines of bright galaxies. We now know clearly that black holes drive large-scale structure in the universe from their home in these galaxies. And we now have an entirely new way of studying general relativity in black holes that we never had before. And as with all great discoveries, this is just the beginning.